Hello everyone, my name is Taylor Gapczynski. I'll be doing a demonstration video on Faraday's law of magnetic induction for MAE 535 Design of Electromechanical Systems at North Carolina State University. Faraday's law states that in any closed circuit, a timed rate of change magnetic flux linkage will induce an electromotive force, or EMF, in the current carrying conductor. I defined lambda as the flux linkage, which is another way of stating n number of turns in the circuit times the magnetic flux density. Here I've defined my guitar pickup with this simple diagram: a permanent magnet wrapped in n number of turns of copper magnet wire. I have my guitar string sitting above the magnet. Usually this is a steel core string coated in a nickel alloy. I've drawn my magnetic flux density lines in red. Okay, for this demonstration, I'll be using a fluke meter to measure resistance of the guitar. I'll be using a Pico Technology Picoscope 2000 series to record voltage, and I'll be using a Metternich electromagnetic field intensity meter. On this electric guitar, I'll be plugging my Picoscope and multimeter into the pickup selector. Okay, about 3.85 kiloohms across the selector, my intensity field meter, and the scope program used to record the induced voltage. Plucking the low E string, we can see the voltage wave that is produced in the coil from the vibrating string. Pluck it again. And my meter's a little far away, but about 0.2 microtesla. Now that I've demonstrated Faraday's law of magnetic induction on an electric guitar, I'm going to demonstrate it again using a simple model of a single coil pickup. This is a neodymium magnet, about 9 of them, wrapped in 22 gauge copper magnet wire. There's about 100 turns of wire in this magnet, and I've hooked it up to a breadboard as shown with just power and ground, and I have my scope leads into the circuit. Okay, my first demonstration will just be moving another neodymium magnet above this one, showing the scope waves of the induced voltage, and then I will play my acoustic guitar over this magnet and show you the induced wave. I will now demonstrate this single coil pickup by waving another neodymium magnet above it. So there's the induced voltage wave. My EMF meter is reading anywhere from about 14 microtesla down to about 8, depending on how fast I'm going and how far away from the magnet I am. So my single coil pickup is working. Okay, now I will demonstrate strumming or plucking the low E string on an acoustic guitar over the pickup. About 0.17 microtesla. I don't think I saw much of a wave in the voltage. Let me stop the recording. Go back to one of the earlier starts. Seeing a lot of noise in the data, but not a lot of structure as far as strumming. So waving the neodymium magnet above my pickup had the best response. The EMF meter was reading about 14 microtesla most of the time, and the voltage wave was very defined. Plucking the low E string on the guitar did not produce the kind of response I was hoping to get. Perhaps the phosphor bronze strings are not as strong as the steel core strings on my electric guitar. Additionally, the number of windings of copper wire around my magnet is not very high. Most pickups would have numbers of windings into the thousands. But I hope this was an educational and entertaining video of Faraday's law of induction, demonstrating with an electric guitar and a single coil pickup model. Thank you.